Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to balance a how to balance a redox reaction in basic solution using the half reaction method. So in the previous two videos that I posted, I was showing you how to balance redox reactions in acidic solution. In this video, I'll show you how to balance it in basic solution. It is literally the exact same way of balancing a redox reaction in acidic solution with the added step of neutralizing your H plus by adding OH minus, the hydroxide ion, to your equation. So let's get into this. So here the equation that we have is the redox reaction we have iodide, so we have the iodide ion reacting with permanganate ion, and that's going to form I2, your iodine element in the aqueous solution, and solid manganese 4 oxide solid. So first step always in balancing your redox reaction is to assign your oxidation states. So once again, if you have an ion that's monatomic, then the charge on the ion is the oxidation state. So the oxidation state of this iodide ion is -1. And if you have an elements in their standard states always have an oxidation state of 0. So this has an oxidation state of 0. And then when we're looking at polyatomic ions or ionic substances or molecules, the oxidation states of all the atoms that make up the polyatomic ion or the compound that we're looking at should add up to the total charge that is on that compound. So if we look here, we have the permanganate ion. So here we got manganese and we've got oxygen. So because we have manganese and oxygen, we have to assign oxidation states to those, and someone's going to have preference. So in this case, oxygen always takes precedence over the metal. So we assign oxygen a oxidation state of -2, unless of course it's a peroxide. Then in that case, it'll have a -1 oxidation state. But here we have a -2. So oxygen has a -2. Let me write that better. So oxygen has a -2 oxidation state. We have 4 oxygens, so that's going to be a total of a -8 for the oxidation states of those oxygens. And we know that the oxidation states of all the atoms and ions must add up to the total charge on the substance. Here, the permanganate ion has a -1 charge on there. So the positive and the negative have to add up to a -1. We have a -8, so manganese, being the metal, should have a positive charge or positive oxidation state, and it's got to be +7 because 7 plus -8 gives us a -1. Okay, so manganese has a +7 over here. What about over here? Same thing. Oxygen is going to take precedence. So here we have oxygen has an oxidation state of -2. Here we have 2 oxygens, so that means the total is a -4. And then that means that the manganese in this case has to have a charge that's going to add up to the total charge on the substance. Now that -2 is the oxidation state of the oxygen that I wrote down. It's not the charge on this substance here. This substance has no charge, so therefore the manganese has to have a charge that equals the total negative for the oxidation states of oxygen. So that means that the manganese has to have a +4. Let me write this over here so that it's not confusing. So then oxygen, So oxygen has a -2 oxidation state for oxygen. This substance has no charge, So the manganese has to have a +4 that balances the oxidation states of the two oxygens. So now we got the oxidation states written down. We can divide these up into oxidation half reaction and our reduction half reaction. So we're going to our mnemonic devices, oil, rig, or leoger. So oil is oxidation is loss of electrons. So what happens to iodine? So iodine goes from a negative to 0. So remember, oxidation is loss of electrons. Loss of electrons, electrons are negative. If you lose negative, that means you become more positive. So here we're going from a -1 to 0. That's less negative, more positive. So the iodine is going over oxidation. So here we got iodide ion, aqueous, going to I2, aqueous. So this is our oxidation half reaction. And then here again we have manganese. Oxygen, you notice oxygen keeps its oxidation state, -2, -2. So oxygen is undergoing no process. It's not losing electrons, it's not gaining electrons. But manganese goes from a +7 to a +4. So it gained 3 electrons. So in gaining electrons, it got reduced. So that's reduction. So here we're going to write the reduction half reaction. So we have MnO4 minus aqueous goes to MnO2 solid. Okay, we have our two half reactions. Now the next thing to do is to balance them. So we're first going to balance the atoms, make sure the atoms balance out, and then we'll balance the charge. So here we have 1 atom of iodine, here we have 2 atoms of iodine. So we need to put a 2 coefficient here. So now the atoms are balanced on this side. Let's go over here. Now over here, we have 1 manganese, 1 manganese. Good. Here we have 4 oxygen. Here we have 2 oxygen. So what we're going to do is we're going to balance the oxygen by adding water. So we add 2 waters over here. So, oops, forgot my 2. So 2 H2O liquid on this side. So now I have 2 oxygens, that's 4 and 4. But now that I've added 4 hydrogens on this side, that means I have to add 4 hydrogens on this side. And again, I'm going to use H plus to balance. And that's aqueous. Okay, now you're thinking, well, Mr. Koval, you said this is a basic solution, so why are we having the H plus? Isn't that for acidic solution? And you would be correct. However, this is where the hydroxide comes in. So this is basic solution. So we're going to use the hydroxide to neutralize our H. So again, I have 4 over here. I should have 4 over on this side. So I'm going to add hydroxide. So this is the extra step that you need to do when you're balancing redox reaction and basic solution. Once you add the H plus ion, you've now got to neutralize it with your hydroxide. And if you add hydroxide on this side to neutralize your H plus, you've got to add the same number of hydroxides on this side. So I have 4 H pluses over here, so I got to add hydroxide, OH minus on this side. So OH minus aqueous, and I'm going to have 4 of those. And I'm going to add 4 on this side. So plus 4 OH minus aqueous. So now I have OH minus 4 on this side, 4 on this side. So everything is balanced. Now notice here, what do I form when I have 4 hydroxides and 4 H pluses, or hydronium ions, if you want to think of it that way. Both of these together is going to form water. So I can rewrite this as 4 water molecules. H2O liquid plus MnO4 minus aqueous is going to go to MnO2 solid plus 2OH2 liquid on this side plus your 4OH minus aqueous on this side. So here now is the balanced equation for the reduction half reaction. But I'm not done yet. Notice here that I have four water molecules on this side, and I have 2 on this side. If I have something on both the reactants and product side, I need to cancel stuff out. So since I have 4 on this side and 2 on this side, I can cancel 2 here and 2 here. So then this is going to become a 2. And this is going to become, I'm going to get rid of this. I'm going to get rid of it. So now I have 2 waters on this side plus my MnO4 minus aqueous on this side. And then I'm going to have my MnO2 solid, and I'm going to have my 4 hydroxides on this side. So now you can see that it's basic, right? So this is now in a basic solution. No H pluses are here. So now I have my final version of the reduction half reaction. So now it's time to add these together, but wait, we're not done yet. So we need to balance charge, right? We finished balancing the number of atoms, but we haven't balanced charge yet. So notice here I have 2 negatives, and over here is neutral. So to get them to both be negative, I'm going to add 2 electrons on this side. So for here, I'm going to have 2I minus aqueous, and that's going to go to I2 aqueous plus 2 negative electrons. Okay, and then same thing over here. I have 2 waters that's neutral. I don't need to worry about those. I have a -1 on this side, and I have neutral on this side, and I have 4 negatives. So I have 4 negatives on this side. I have 1 negative on this side, so I need 4 negatives here. So I'm going to add 3 negative electrons. So here I'm going to have 2 H2O liquid. I'll just add let me add the 2 electrons, or the 3 electrons first. So I'm going to add 3 electrons this side plus the 2 H2O liquid plus the MnO4 minus aqueous goes to MnO2 solid plus the 4 hydroxides aqueous. Okay, so now I have my charges are balanced. Charges are balanced here, charges are balanced here. Now I need to make sure that I have the same number of electrons on both sides. So I have 2 electrons here, 3 electrons here. I'm going to have to multiply each equation by a factor so I can get the same number of electrons. So I'm going to have to multiply this equation by 2 because 2 times 3 is 6. I'm going to have to multiply this equation by 3 because 3 times 2 is 6. So then this equation is going to be multiplied by 3, and this equation is multiplied by 2. So let's go ahead and write this out. So 3 times 2 is 6. So I have 6I minus aqueous, and that's going to go to 3I2 aqueous plus 6 negative electrons. I'm going to multiply this. Let me put a line here to separate those two more clearly. And now I have 3 times 2, so that's going to give me 6 electrons on this side, plus 2 times 2 is 4, so I have 4 H2O liquid, and then 2 times 1 is 2, so that's going to be 2 MnO4 minus aqueous. And then we'll multiply this by 2, which is going to be 2 MnO2 solid, plus 2 times 4 is 8, and then that's going to give me 8 hydroxides aqueous. Okay, so now everything is balanced. So I have the same number of electrons. Here I have 6 electrons as products. Here I have 6 electrons as reactant. Product, reactant, cancel each other out. 6 is gone, 6 is gone. Now I add these together. So I have 6I for my reactants. So 6I minus aqueous. That's just one reactant here. Now I add these 2 reactants. So plus 4 H2O liquid plus the 2 MnO4 minus aqueous going to products. So my product here, 3I2. So I have 3I2 aqueous plus, and then I've got these 2 products here. So 2 MnO2 solid plus 8 OH minus aqueous. And so now I've got my balanced redox reaction. So we can always double check. We can double check that the atoms are balanced and that the charge is balanced. So I have 6 iodine here. I have 3 times 2, 6 there. I have 4 times 2 hydrogen, that's 8. And I have 8 times 1 hydrogen, that's 8 there. I have 4 times 1 is here, that's 4 for the oxygen here. And I have 2 times 4 is 8. So 8 from here plus 4 is 12. So I have 12 oxygens on this side. And then here I have 2 times 4, or 2 times 2 is 4. And then I have 8 and 4 is 12 oxygens on this side. And then finally I have 2 manganese and 2 manganese. So the atoms are balanced. What about charge? Here I have 6 negative. This is 0, so I don't need to worry about that. 6 negative, and then 2 negative. That's 8 negative on this side. Here, this is neutral. This is neutral. And I have 8 hydroxides, which are negative, 8 negative on this side. So charge is balanced. So that, ladies and gentlemen, is how you balance a redox reaction in basic solution using the half reaction method. I hope this was helpful. If you enjoyed this video, if you learned anything from this video, if this was helpful in any way, then please, by all means, like the video. Hit that like button. Also, by all means, subscribe to my channel. hit that notification bell. And when you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.